Morning. Hello, everyone. I'm Adam Ellis. So the aim with this short webinar today is to provide some useful information based on our experience in tech support over the years, plus some of our own experience in service and calibration. Often what we hear are problems typically after maintenance shutdowns at summer or Christmas, and we hear this from all regions globally. Some regions are better than others. Typically we hear about total failures, communication issues, but also questions like, I don't get the reading I expected, or I keep having to adjust the set point, or the readings aren't logical. But before we get into that, let's share a little information about who Fluke Process Instruments are. So we're part of the Fluke Corporation, which is part of Fortive. Fortive are based in Everett, in Washington State, in the US, which is close to Seattle. Totally, we're more than 20 companies with over 24,000 people, and we're split into two distinct groups. So FPI, as part of Fluke, are in the professional instrumentation section, and the other section is industrial technologies. But Fluke Process Instruments as a brand started in 2015, bringing together Raytec, Ircon, and Datapack. So we make non-contact temperature measurement and thermal profiling products. We're able to offer customized solutions for end users, and we also supply OEMs. Datapack started out designing systems for use in the coatings industry, as one of the founders came from a coating supplier and wanted a reliable method of measuring temperature from within a process. The Datapack solutions are all based on the same basic principle of passing a logging system through an oven or other process to measure product and air temperatures. Over the years, the concept was taken further and applied to all industrial heating processes, from the cooking of food, the curing of coatings, electronic soldering, metals, heat treatment, and ceramic firing. On the infrared side, Raytec and Ircon both started around the same time in the early 60s, developed non-contact temperature measurement products for slightly different customer bases, and we were integrated into one infrared family in 2007. Globally, we've got offices in the US, in the UK, China, Japan, Singapore, and India. And in terms of manufacturing, mainly we manufacture in Germany, but then also in the US and in China. So the aim of the presentation is to help prepare, hopefully reduce or eliminate issues that may arise after a period of inactivity. You could also take it as general advice that may have a few useful pointers not thought of before. Some of the information can be used as a reference, and we'll send a copy of the presentation. Consider, though, that this may describe worst case scenarios. Many situations are likely to be problem-free, so this is a consolidation of what we see. If you don't use cooling or purging because it's not a harsh environment, lenses are covered during shutdown and the units aren't touched, probably there's nothing to do. If they're not readily accessible, so that on one hand the alignment can't be disturbed, at a very minimum you need to check the lens for cleanliness contamination. If you do use purging or cooling, there are further things to consider and avoid: undercooling, overcooling, lens contamination caused by not enough air purge, or sometimes too much air purge, or even actively contaminating or damaging the lens over time. So we'll show some examples. So this slide shows what happens when mistakes are repeated over time. Both lenses were taken off of long and medium wave TX sensors that came into service. They're both used in fairly harsh environments. So on the left is from an asphalt or roadstone plant, and on the right it's taken from a medium wave gas sensor used in an incinerator. Both applications used protection tubes, but none used protective windows. The lenses themselves are made of Amtier, and they get fitted to sensors that can measure up to 1650 Celsius. So they can be used in fairly harsh environments, but they are relatively soft compared to other optical materials. And what you see here is really the effect of some kind of maintenance, but really where the windows or the lenses were cleaned with a dry cloth. So some contaminants, some dust, but not really following the proper procedures. After we replaced these lenses in service, both customers were encouraged to buy protective windows, and they did. So moving on to our rogues gallery, these are typically, they're representative samples of windows fitted for 6 months with really poor maintenance. Fitting windows doesn't avoid or reduce the need for maintenance. Effectively, what they serve as are sacrificial items, which saves you having to return the devices to calibration or to service to be repaired, and that saves money and time. On the left, we've got a good condition window. It's a very small effect of cleaning, but generally good maintenance procedures. The next one in is from an asphalt plant that we would do on-site calibrations for, and this is where the user was quite open to say, yes, we clean the lens, we put a cloth on the end of a screwdriver and we poke it up the tube and we wiggle it around, and that's how we clean the windows. That's not the best way. They also will talk about adjusting the emissivity to make the reading suit. Yeah, it's probably about one of the worst maintenance we've seen. The next one is what happens to a window when the air purge fails and the front of the window gets overheated. This is burning of the lens coating. In this case, actually, the window protected the sensor from being damaged. The window was replaced, and everything was fine. On the right-hand side is about the worst we've seen in terms of measurement, and this really is oil or water in the air purging lines. A huge amount of airflow because it was a dusty environment. But with the two combined, the excessive air and creating a vortex, actually the air mixes with the dust mixes with the oil, and over time it just creates a hard paste, and more or less nothing gets through. What the customer did in this was they would just reduce the emissivity setting further down and down and down to get the reading that they expected, and finally there was no further adjustment possible. But they also had some advice about maintenance. So what happens if or when you have a dirty lens or window? So here we've got an example of possible effects. Depends on the nature of the contamination that can affect the reading. And this is a general example. It's not possible to predict all behaviors and contamination, moisture, oil, dust, carbon. They can all have a slightly different effect, but but generally this fits to most. In the first example, we've got a typical ideal condition. The target is not necessarily this piece of glowing metal, it's just as an example. But it's more the fact that we've got a sensor with a sighting tube where the optical characteristic of the sensor is good, and we don't have any interference from the sighting tube. And then our example with a standard single color or a ratio sensor would show that both readings would be the same. 800 is just a nominal value. If you get a dirty lens or dirty window with a standard single color sensor, we would expect the reading to go down. We would also expect a ratio sensor to probably stay the same. But what possibly that we don't consider, or generally don't consider, is that with optical contamination, we can also, in some cases, affect the distance to spot size ratio, which could effectively give us a larger spot size, which you may not see with ratio, but you may see with single color. The downside of that is if you've got an application where you have a dirty lens and you have a sighting tube that, due to where it's installed, happens to be, it can get hot. If you have a worsening effect of the distance to spot size ratio, your reading can actually be higher than expected, because we're actually picking up the tube, and you may see that. You probably will see that in a single color and a ratio sensor, but you may not be aware of it. So you just think that you've got an over reading, but the reading's actually caused by a dirty lens. It's really to reinforce or come to a general conclusion that optical quality and regular inspections are really a must-have. It could also be said that the example of worsening D2S on a system with just a window could be slightly than with a sensor with just a lens, but it's just not possible to predict. So it's general advice, but you can, and we have seen this kind of either self-cancelling or higher reading effect with a dirty lens or window. I'm just moving on, a bit slow. That's it. Okay, right. So here we've got a quick overview, purely as a reference to show which devices are delivered with a lens and which are delivered either with a window or have a window as an option. So the Endurance one-piece sensor and the line scanner are both delivered with the front of the sensor being windows rather than lenses. All the other devices have protective windows available as an accessory. Now, accessory windows can be ordered and fitted during manufacture, and a transmission value is preset in the device if you use the I suffix when you order. If you don't use the I suffix and they're fitted after installation or as a spare part, then you need to adjust the transmissivity or the emissivity if the transmissivity is not available. The general rule of thumb is a window can be removed, cleaned or replaced on site, and a lens can't. And this may just serve as a reference, also to show, okay, that you need tools to replace the window on the Endurance. For the fiber optic Endurance, it's just use the hands, it's a screw on. For a line scanner, you use tools that is slightly more involved than the Endurance. T4.0 and ThermAlert, ThermaView and the MI3, they're just screw on windows. As I said before, the Endurance has a window, but it's part of the design. You can buy it as a low-cost replacement. You can change it in the field. It's supplied with an O-ring, but a window has to be fitted to this sensor at all times. Fiber optic sensors have an add-on window which isn't compatible with air purging, but we've other accessories with air purge that also come with Sapphire windows. For TX, Thermalert, and XR, there's various window types available, not just for the wavelength, but also the application. So for example, low temperature T4.0s can use zinc sulfide or a polymer foil, for example, for food applications. A calcium fluoride can be fitted to many of these versions up to P7, and Sapphire, many versions up to MT. So you're really able to choose the right window for the application. For the ThermaView, we've got a fixable window. It uses the bayonet mount, but it's only a protective window for the standard version. MI3, the windows are different between MI3 10, 20, and MI3 100. And we also have food compatible versions for the LT sensors, which are just a polymer. Replacing the window on the line scanners. Line scanner is good if you're maintaining one in the field, because you do have a degree of flexibility for on-site maintenance. All windows are the same material and identical between MP150 and ScanIR3. Each window is supplied with a corresponding transmission value that's entered into the running line scanner software. It's completely independent of the recipe or INI file. If you don't have this value, actually it's not so risky to use the existing factory value. It could be argued that the accuracy is slightly affected, but it's also highly likely that it's still within the standard specification. It's always worth checking in the supplied manual, if you know where it is, because we actually supply a spare window with each new scanner. Now the windows are flexible because they're a curved fit, but they're also slightly fragile. You can bend them, but they have limits. They also don't withstand a great deal of impact. So with mechanical impacts in the wrong direction, you can damage them, but generally they're fairly easy to replace, and there's a procedure for that in our manual. Now you can use any of these. If you've got a window with different spectral information on there, you can use any of them in any scanner. If you've got access to a black body, you can adjust this value to 1, take a reading without the window, and then put the window on and adjust this until it's the same. In an emergency, quote unquote, you could do this on the process. If the process is stable enough, you couldn't do it on a float line, for example, but you could do it on a cement kiln. But nevertheless, there's a fair amount of flexibility with the line scanner for on-site maintenance. The windows are also available to buy. Moving on to lens cleaning. Cleaning the lens sounds like a very basic task. Who really needs training? What we see in the field tells us that there is room for improvement. For devices with a glass window, like the Endurance, you generally probably get away with a squirt of lens cleaner and a microfiber cloth. The Endurance window is made of crown glass, and is actually quite resistant to scratching and quite low cost to replace. Other sensors, especially lower temperature sensors with softer crystal type lenses such as silicon, germanium, amtir, zinc sulfide, you need to be more careful. Clean them like they are expensive spectacles, essentially. The golden rules are: wear gloves, don't use ammonia, and never wipe the lens or window when it's dry. Cleaning is a 2 or 3 step process with the removal of particles as much as possible. Then remove any film or emulsion, possibly a 3rd application of liquid cleaner, wipe and then let air dry. Wearing gloves are for 2 reasons. One is to avoid recontamination of the lens after cleaning, maybe with oil from the hands. The other is for when certain contamination and or overheating can cause the lens coating to break down. You don't want to have residues of that coating on your fingers. That should be avoided. So this slide, these are real photos of units that we've either seen on site or that we've had back into service. Practically, we know, and customers have learned over time, that overcooling can be as bad or worse than undercooling. So typically, undercooling or overheating, an overheated device will stop working once the microcontroller exceeds its maximum temperature. Sometimes it can recover and start working again after cooling down. In any case, the effect is quick to notice. There are limits the amount of overheating the devices will take, and typically once a limit has been reached, as detected by an internal temperature sticker, the device will be classed as a total loss. That means if it's overheated past a certain amount, everything needs to be replaced, because if you replace the failed component, you don't really know what the effect is on other components that may appear working but may fail after a few weeks. Overcooling, well, that's insidious, and it allows moisture to build up over time. It will condense and then slowly get to work, corroding the electronics. You may notice, or even worse, you may not notice, strange behavior, unusual temperature readings, erratic behavior, noise, warnings in the software, and you'll get that before real permanent damage is done and the unit stops working. And in this case, once a unit is as bad as this, and in this case, this is in a humid country with cooling actually not turned off during shutdown. This would also be, both of these cases are completely beyond economical repair. So having covered the importance of having and maintaining a clean optical system in a startup, what's next? Well, we move to checking the alignment. On the different devices that we offer, there are a number of sighting options. There are also sensors that don't have any sighting. The endurance sensor offers 4 types of sighting. Laser is the classic. You have a pinpoint that shows the center of the spot size. On endurance, that laser dot is sharp when it's in focus, and it's kind of blurred when it's not in focus. That's because the unit is focusable. On units that have a fixed focus, the laser dot is just a laser dot. Then we have the LED sighting, and the advantage of that is that you see this, you're shown the spot size at all distances, and that can be, depending on the setting of the focus, very useful with sighting tubes or any other restriction in the optical path, because it really shows you the spot size at all distances. Video is useful. In this case, the center spot is a superimposed reticule in the video view using our software. Video view offers the advantage of also checking for blockages in a sight tube or path, in some cases contamination. Through the lens is the standard. On the Endurance, you get through the lens sighting plus one of these. The line scanners also offer laser sighting, but that's a laser line. It shows you the center line, even if it doesn't show you the complete field of view. Air purge pressure and cleanliness. Well, you've made sure that the lenses or the windows are clean, and if you're starting back up again, it could be, and we have seen this, the airlines can have moisture in them. So we would typically always advise that airlines are disconnected and allow moisture to clear so that you get clean air flowing before you connect them back up. We also often see simple ball valves or taps that are closed during shutdown. And quite often, if you've got different people starting up that compared to the maintenance teams, they'll often just open the valve to maximum. And it may not have been like that before. There is a danger, and we've seen that with too much air purge. One, you can actually cool down what it is you're measuring. The other, we've seen this in high dust applications, that too high a volume and sight tubes and a lot of dust, sometimes you can create a vortex which actually ends up making the lens or window dirtier quicker. The standard is too low, is also completely ineffective. And the general rule of thumb actually is that you only really need to create a positive pressure in front of the lens to prevent anything getting close to the lens. It doesn't need to be a blast. Quite often we get asked, okay, what's the gauge pressure that we need to dial in? We only really publish flow specifications. Quite often the amount of gauge pressure that you need to dial in, sometimes, especially on MI3, for example, may not even be registerable, but it's really just to keep a positive pressure. Preventing moisture on the lens is important, but also preventing moisture inside. Where the devices are installed, it's also necessary to consider the ambient temperature, the temperature around the device, the sensor or the scanner, but also the humidity. We generally recommend not to use chilled water below 10 degrees, but also in the manual or manuals, we have a guide for the humidity and the ambient temperature to define a minimum internal temperature. If the sensor is too cool inside, it will defeat the IP rating. Moisture will, even if, for example, you've secured the cable correctly in gland fittings and you've preserved the IP rating in that sense, cooling the sensor down will really draw moisture in past O-rings and window gaskets and that kind of stuff. So it's really important not to overcool. I've seen a line scanner on a still line in Slovenia a few years ago where the scanner was removed, and when you take the window off, you could actually pour water out of it. It was that bad. Warm-up. I guess warm-up's kind of interesting because we do publish warm-up specifications even for devices that aren't internally heated. In endurance ratio on the line scanner, there is active heating or cooling, and that cooling makes heat. So there is a warm-up time for the active heating or cooling of the detector. But it's also good generally to allow some time before relying on the readings for general warm-up. In terms of the endurance sensor, the ratio sensor will give a warning ECUU as it's warming up, but that error code will disappear and it will give a reading. But the main part of the endurance is if the green LED is flashing, then you still need to wait for the unit to reach stability. One other consideration could be with systems that use a shared power supply. Inrush current can be, I wouldn't say it's an issue, but it's a consideration. I've not put it in the slide, but it's worth mentioning. We also know that in most applications, power supplies are adequately rated. From time to time, we do get problems, especially when sensors or devices are added into systems where there's an existing supply, where the continuous power consumption of all devices gets fairly close to the rating of that power supply. If all the devices are powered on at the same time, it could be that startup current is exceeded. Some devices don't start quite as expected. It's just something to consider. We also believe that the best designed systems have circuit breakers on the DC supply side and not just the AC, and that can often have a positive impact. If you switch to DC, so that if you're stopping the AC, the power supplies aren't slowly decaying and dropping down, the sensors still have power right to the limit. Again, it's not something that we see often, but it can be a consideration. The last part really is if you've got a sensor that you are actively purging or actively cooling. If you start the sensor up and it's stabilized and then you initiate purging or cooling, you need to wait a small amount of time for the device to reach an equilibrium. Ideally, the purging and the cooling is running for a long time before the sensor's powered on, so it's not a consideration. But if it is started after, that initial cooling effect and cooling effect of the lens just needs some time to stabilize. Devices with a display, you can check what the temperature is, and the idea really is to ensure that it's not in a changing state. On all devices, you can check the ambient or the internal temperature in the software, and you can also program an inbuilt relay to protect or to at least warn if the device is outside of limits. Finally, a little word from me personally in tech support. We are here to support you. I run a small dedicated global team. We run a ticket system which you can go online to send us a message. We typically run from Pacific time in the US to the evening time in Asia, which gives us about 20 hours of coverage. It's not so important who picks up a ticket. If you're really early in the morning in Europe, the ticket can get answered from India. But if you're in the evening in Europe, where we might be closed in the UK or Germany, my colleagues in America can answer. We try to be as fast as possible. But what we do within this platform is we continuously create FAQs, calibration guides, how-to documents, and we update those weekly. At the moment, we're running at about 5 or 6 updates a week. We need to find a way of broadcasting when we make something new. The other thing that we can do, and it's certainly not new, but we're doing it more and more these days, is we can configure systems remotely via TeamViewer. In the US recently, we've managed even complete cement system startups by TeamViewer and telephone. We do that probably daily. And then finally, we have a spot size calculator that you can see online and use. And with that, that's the end of the presentation. Hopefully it's been of some use. I'd like now to turn it over to Enrico and answer any questions.
Yeah, thank you, Adam. There is a couple questions coming in. There is one. Is there, the way I read the question is, would we recommend always an additional window, or is there an additional window necessary?
I think if the application is such that the lens would need cleaning more frequently than monthly, then I think it's worth having a window. If it has to be cleaned 12 times a year because it's getting dusty, having a window won't prevent that from needing to take place, but it will. I mean, purely from a sales point of view, I think everybody should have 2 windows, one to be used and one spare. There are some applications that aren't suitable for windows, and applications in sort of sub-zero or where the object is close to the ambient temperature, or you might have a possible changing ambient conditions. If it's a clean area and you've got that, then you don't need a window. But yeah, as a rule of thumb, if you have to clean it monthly, have a window.
Yeah, so now I read the full question, Adam. So do you have any tips for installing Thermalot 4.0 unit on the tank with resin fumes? Is there aperture enough or additional windows necessary? That was a full question.
With resin fumes, I would have a window. Purge might be enough, but it's difficult to say. I think if a resin could condense and be impossible to clean, I think for the relatively low cost of a window, I would have a window.
All right. Then we got one more question. How can I check the focus of my parameter if I don't have a laser or sighting view?
Oh, yeah, very interesting. I guess. Well, I mean, it partly depends on what the sensor is, and for example, if it's an MI3 with a distance to spot size ratio of 10 to 1, then you know your spot size is 10% of your distance, and it could be that even from a few meters away, you can stand behind it and approximately know where you're looking. In addition to that, all you can really do, apart from have some kind of mechanical guide with a tube, is to adjust the sensor in the X and Y axis, assuming that what you want to measure is hotter and maybe discrete until you get the maximum reading. Yeah, that's all you can really do.
All right, there is another question. If I have an MI3 with the MIACAJ, how can I install a protected window?
Well, there's a couple of ways you can do that. We've got a little document that shows how you can extend the internal length of the air purge collar, which involves, and it's not factory approved, but we've implemented it ourselves. Christian and I have done that, fitting close focus adapters to MI3s with air purge collars on a cement system in the US. You modify the Teflon ring that allows you to put the protective window on, and you extend the length of the air purge collar and seal it with some aluminium tape. It's not very elegant. We do have, actually, one of our channel partners has made a plastic or polymer air purge extender, which does exactly that. I've got that in a little library of local accessories, but it can be done. If anybody wants to do that, I can send them a little unofficial how-to, and it works because we've done it ourselves.
Thank you. So there's one more, which I think is more a question for clarification. So, and I can answer that, or you, Adam. So now Fluke is also ranging scanners with a field of view of 120 degrees, like Thermotechnics or FL Smith Automation. You want to respond to that, or I can? So
you can respond to that. Yeah.
Yeah.
That's more
so so that's not the case. So our line scanners are still running with a 45 or 90 degrees field of view. I think in terms of the question is probably related to our cement systems. And I think we have different benefits and advantages apart from the 120 degrees field of view with our systems. So, and no, it's not the case that we have that.
No, and I don't think it's coming in the short. Certainly, it's not coming in the short term.
Yeah.
We do know the biggest challenge comes when you have to put two scanners of ours compared to a single scanner system of a competitor, and the price tends to be somewhere in between. The 120 degree field of view is typically more costly than our one scanner system, but less than our two scanner system. Finally, in some regions, that's never been an issue. Even putting in 3 and 4 scanner systems in the US, where we've actually taken out Thermotechnic systems, 120 degree field of view isn't, if you like, the panacea or probably the most important specification. There's a lot of unique parts if you've got restricted distance, and it affects some applications, but it doesn't affect any. It would be a nice to have maybe, so that we could use it if we needed to. But yeah, it's not something that's coming in the short term.
All right. There's just the matter of time, Adam. Just probably a quick answer. So do I need to reconfigure the settings of my sensor after a long shutdown?
No, all sensors are saved in non-volatile memory. So no, they're saved.
All right. With that, we don't have any further question. So if you want to close the webinar.
Yep. I think there's nothing more, no leader. But thanks everybody for joining us. Any further questions, we're happy to take them by email or through Freshdesk as you need. Thanks very much.
Thank you.